Hey everyone, how are you all doing? Well, in today's video, let's discuss the part 2 basics of sets. Let's begin. Here we have the topics that we are gonna cover today. One is what are the subsets, properties of sets with subsets, what are power sets, and we are going to solve questions on both lecture 1 and lecture 2. So let's quickly begin. What are subsets? A is called subset of B if all elements of A are present in B. Now I know it seems to be like German. Let me explain you. Here A is equal to 1, 2, 3, let's say. B on the other hand is 1, 2, 3, 4. Now, what is the condition for A to be the subset of B? That means B is the king and A is the soldier. How can that be possible? Only if all the elements of A are present in B. Okay, now I should have a look at this. 1, 2, 3. These are the three elements. Are they present in B? 1, 2, 3. They are, right? Irrespective of what is present in B, you're gonna check what is present in A and are the elements that are in A present in B. That is your business. That's it. Do not look into the other elements of B. Just if A satisfies B, that means the elements of A are present in B, then A is called the subset of B. Remember, A is called subset of B if the elements of A are present in B. So it is in this manner, AB, AB. Alright. What is the statement? You're going to learn the statement as well. Okay. A is called the subset of B if all the elements of A are present in B. That is known as a subset. Here, A is called the subset of B. Fine. Now, if you move on and discuss the properties, you'll be able to get it better. Properties of subsets. The first one is every set is a subset of itself. Now if I say A is equal to 1, 2, 3, 4. Now what would be a possible subset of A? Now I can write the subsets of these as, I can write the subset of A as 1, 2, 3. Now B is 1, 2, 3. That means if all the elements of B are present in A, then B is a subset of A. Now what if I say, here I'm going to add on 4 as well. Isn't that the same set? Can I name this as A only? This is the subset of A. Now you might ask me, how can it be a subset of A? Here 1 is there, 1, 2, 2, 3, 3, 4, 4. If all the elements are there, if the elements of A are present in this A, then it is definitely a subset of A, isn't it? So, what would be the conclusion over here? Is there any change in the elements that I have displayed in this set and this set? No, isn't it? They are the same sets. That means every set is a subset of itself. Now, if I say, write a subset of B is equal to 1, 2, 3. Now, it should come to your mind that one of the subset would definitely be 1, 2, 3. Isn't it? Now, if I say, write this subset of C is equal to 1, 2. Now, you must get into your mind that one of the subset would be 1, 2 itself. So, every set is a subset of itself. One most important thing. Secondly, we have the second property which says phi is subset of all sets. That means What is phi over here, everyone? This is the empty set. Oh my goodness, this is the empty set. It is the subset of all sets, isn't it? We have seen previously in the types of sets that empty set would be a subset for all the sets. Alright. Now if I say B is equal to 1, 2, I'll quickly tell you, write a subset of this. One of the subset would definitely be 5. Hey? You might be wondering, there is no element called phi in this. How can it be the subset? Well, let me tell you, this is not an element over here. This is the set itself, right? So empty set is the subset of all the sets. Alright. Now, while you're writing the sets, when you move on to the next slides, you'll be able to get into a new topic, that is power set. I'll let you know there. Alright. You need not worry about the second one. We'll take it back in the power of sets or the power sets. All right. Now, if I need to talk about this, if A is the subset of B and B is the subset of A, then A equals to B definitely, right? If I have A and B, if I have A as 1, 2, 3, B as 1, 2, 3. All right, let me take B as 3, 2, 1. It does not make a difference, yet I'm showing you. Okay, now I can say that A is the subset of B. Simultaneously, I can also say that B is the subset of A. That means here A is equal to B, isn't it? It's clearly evident that all the elements are simultaneously present in both the sets. So A is equal to B. Now let's quickly move on and understand the power sets. Power set. In this, I'm going to explain you what phi was previously. Now, what is a power set? Basically, it's a collection of these subsets. Alright. Now, I'm clearly explaining you now that here, let's suppose say I have set A, which is having 1, 2 elements. Now, if I need to find out a power set, I'll write it out like this. P of A is equal to, now what is a power set, everyone? A number of subsets together aligned in a single set is known as a power set. A simple way to definition. Alright. Now if I need to form a power set for this, firstly go from the very least to the very advanced. Now I'll tell you something. Here, in order to not miss any subset, there is a small formula, that is, if you need to know the number of subsets that are getting formed, this can be very helpful in MCQs as well. Number of subsets formed would be 2 power n. Now what is n over here? The number of elements. Alright, here we have 2 elements. So 2 ka square, it will be 4. That means there are 4 subsets in this power set. Let us know what those 4 are. Firstly, start from the very least basic fundamental subset, that is phi. And that is what I said you, that phi is the fundamental thing for any subset. Alright, it is the subset for any set. Alright, now this was the most basic thing. Alright, now if I need to talk about the next one, the next one will be only one element, that is 1. Fine, I'm being very much clear. Then the second element, that is 2. Alright, and the last one will definitely be the set itself, 1, 2. That is it. And that's what is a power set. Here we had how many subsets? 1, 2, 3, 4. And that is a power set. Alright, this was a way too simpler example. When we move on to the question time, we'll be dealing with few more. Alright. But for now, I want you to just remember that the number of subsets that are getting formed is equal to 2 power n. And apart from that, make sure you know that the first subset of any set would be phi, and the last one will be the subset itself. In between, you'll write down the single elements, 2 elements, or 3 elements depending upon the set. Let's discuss. Come on, it's question time. Let's solve few. Here is question 1, which is taken from lecture 1. That is, write the set. We have it in the roster form. We have to write it down in the set builder form. All right. Now have a look at this. Is anything coming into your mind? Can I write this as 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5 and so on? Isn't that? 2 power 0 is 1, 2, 4, 8, 16, 32 and so on. Now have a look at this. Isn't it? It is in that form. Now that you guessed it right, we are going to build it in the set builder form. How do I do that? I'll simply write down in curly brackets x such that this 2 dots over here represent such that. With that we have already discussed previously, but still I'm just reminding you all that this is such that. Alright, x such that x is equal to 2n. Can I write it in this manner? Yes. And now if I write n like this, and if I close the brackets like this, that's not going to happen. It will go to infinity, huh? Isn't it? That is, firstly the set itself is an incomplete set. Here, if you write down 2n, now did you give any value for n? No, isn't it? So it cannot be left like this. Firstly, right? Here you got to write where n is equal to, is it a natural number everyone? No, right? 2 power 0 was 1 previously. So you'll involve the whole numbers. But you'll not simply write whole numbers over here like this and close the bracket. No, because whole numbers can be from 0, 1, 2 till infinity. But here it is a finite set. So here I'm not gonna be lazy but write down the 6 numbers. That is where n is equal to 0, 1, 2, 3, 4, 5, 6. Well, that was the set builder form. Now, is there any thing that is missing over in the set? No. Here x such that x is equal to 2n, fine. Where n is equal to is also given. So, in place of n, the set will act smartly and put 0, 1, 2, 3, 4, 5, 6 like that and find out its roster form. Alright. Whoa, what is this over here? Well, do not get confused. It is the same fundamental that we are applying everywhere. Here, firstly, put on the curly brackets. I'm writing x such that x is equal to 1 by n. Can I write it in this manner, everyone? Firstly, where n is equal to, oh, I'm not going to write is equal to, I'm going to write belongs to. Let me be advanced, right? N belongs to natural numbers. That is, in place of n, the set machine will put 1 by 1, 1 by 2, 1 by 3 and so on. That is what is the set over here. Alright, now in this way you build on a roster form to the set builder form. Well, here we have the power set. If I say A is equal to 1, 2, 3, find its subsets. But here I'm not writing just subsets, but I'll write find all its subsets. Now, firstly, how many elements are there? 3 elements, 2 power 3, 8. So you'll have 8 subsets. Fine. Now, if I need to build on the power set, I'll write first of all, let me erase this. I'll write P of A and open the curly brackets, and now here I'm going to write on my subsets. Now this collection of subsets is together known as a power set. Alright, now firstly the basic fundamental stuff that you're gonna write over here is phi. Now you might be wondering, why don't I put this curly brackets to phi? It is not a necessity. Alright, phi can be just left like that. Fine, it has no respect in this chapter. Alright, so it is just left like that. Now there are three elements. Firstly, write down all the three elements in single manner. Single elements must be written. Now we are done with 4 subsets. Now 4 more to go. Right, now let's write down 2 each. First let me write down 1 2, 1 comma 2, 1 comma 2, and then here let me write down 2 comma 3, and let me write down 3 comma 1. Is there any other possible set with 2 elements? No. Now that we are done with all these 7 subsets, what would be the last one? It will be the subset itself, isn't it? It will be the set itself, right? Now, what will be our last subset over here? It's going to be 1, 2, 3. Now, wholly I'm going to close this. That's it. This is a power set. Have a look at the elements. This is element 1, 2, 3, 4, 5, 6, 7, 8. Well, that's great. In this way, we find out the power sets. What is a power set again? It is the collection of all these subsets. Now, P of A here means the power of set A. That means the elements, how many of the elements are there? You're gonna have it over the top like this, right? 2 power 3. If suppose it's 2 power 4, because if there are 4 elements, then it's gonna be 16. So in that way, you'll have your subsets. Well, that brings us to the end of this video. Make sure you hit the like button, share and subscribe. Thank you.